Welcome to another episode of Terry's Notes, and today we're going to be looking at the January 2017 paper, question 5. Okay, so in this question we have a diagram here, and they are saying that triangles PQR and STR are similar triangles. So PQR is this, so that's the outer triangle, and then STR is this. Right? Complete the following statement. So in the above diagram, the corresponding angles of triangle PQR and STR are. Alright, so let me show you something here. I'll try to use two different colors. So if we look at the bigger triangle PQR, this angle here will be equal to this angle here because the two triangles are similar, right? Let me try a different color again. This angle here and this angle here are identical, right? So what we are saying is that the corresponding angles are identical, right? So that's essentially what they're trying to, they say identical or equal, okay? Identical or equal, those are the corresponding angles we are talking about here. And the something of their corresponding size are the same, right? So the thing about similar triangles is that the ratio of the sides are the same, right? So this should be ratio, and let me use the question to explain this. So they said in the diagram RS is 15. So RS, let me write it in one time. RS is 15. So from here to here is 15. SP is 9. SP. So this is 9 centimeters here. And what else? ST is 12. So ST, so this length here is 12, right? So they want to find PQ. So I'll work it across here. Now, the second part of the statement, we said that the ratio of their sides are the same. So what we are saying is that, let's see, which lengths do we have? So the question wants to find PQ. Alright, so we're interested in finding this length here, PQ. Right, that's what we want to find. So what we do know, like because the two triangles are similar, we say that PQ, the ratio of PQ over ST is equal to the ratio of PR over SR. I want you to make sure you understand what I'm saying here. So we have, I'm going to use different colors here. So we have this triangle here, right, which is RST, this triangle here. And we are saying that triangle is similar to PQR, which is this bigger triangle here, right? That is this here, right? So if we look at the bigger triangle, we are saying that the length PQ divided by ST on the smaller triangle, so that's how I said PQ over ST is equal to PR, which is the bigger part of the bigger triangle, over SR, which is for the smaller triangle. So therefore PQ, we don't know what PQ is. ST is 12 centimeters, PR is, hold on, what is PR? That'll be 15 plus 9, which is 24. So this is 24 over SR, which is 15. Right? So to solve for PQ, all we need to do is to cross multiply. So we end up with 15 PQ is equal to 24 multiplied by 12. Therefore, PQ is equal to 24 by 12 divided by 15, which will give us 24 by 12 divided by 15, and we get 19.2 centimeters. So this should be 19.2 centimeters. Okay. So let's look at the second part of the question. So we have a transformation here. We have the graph below shows EDF. So EDF is this triangle here, and its image D prime, E prime, F prime after a transformation, right? So part 1, they said state the coordinates of E. So where is E? E is this point here, right? This is our x-axis and this is our y-axis. So therefore, where is E located? If we bring this down here, we know that this is 4. So therefore, the coordinates of E, we write the x coordinate first, so it's 4. Then we go across to our y-axis and we see that is 2. So the coordinates of E is 4, 2. Pretty straightforward, right? Part 2 says to describe the transformation that maps triangle DEF onto its image, D prime, E prime, F prime. All right, now this is where students get confused sometimes. So whenever we are asked to describe a transformation, it can either be a translation, a rotation, a reflection, right? So if we just look at the DEF and its image, we know it's not a reflection because the orientation of the triangle has changed. It's not an enlargement because the triangle looks like the size has not changed. So it's not a translation, right? Because the triangle should have the same orientation if it's a translation. So just by looking at it, we can see that it could be a rotation, right? Now the thing with a rotation, we need to know rotation about which point, and we also need to know the angle of rotation. So just by looking at it, if I choose the origin as my center of rotation, let's look at the point D. If I do draw a line from the point D to the origin, and I rotate the point D, right? So when I say rotate, I'm going to do this. Right? To get D prime. And this will be my angle of rotation here, which will be 90 degrees. Right? So when they say describe fully the transformation, this is what we need to say. So it's a rotation about the origin, which is 0, 0. What direction are we moving in? We are moving in an anti-clockwise direction. So we must say anti-clockwise direction. And the angle in this case is 90 degrees. Right? So typically when we are asked to describe a transformation and it's a rotation, we have 3 things that we need to say. We need to say, 4 things. We need to say it's a rotation. We need to say rotation about what point. In this case, it's the origin. If we are going clockwise or anti-clockwise, and the angle of rotation, right? And what is the last part? On the grid, draw D double prime, E double prime, F double prime, which is a reflection of D prime, E prime, F prime in the x-axis. So all they're asking us to do is take this triangle here, and we're going to reflect it in the x-axis. So when we are doing a reflection, right, now make sure you understand what the x-axis is. This is the x-axis here. So we're going to rotate along this line, right? When we are doing a rotation, we're going to reflect. So when we are doing a reflection, if we reflect this point f prime, it should be equal distance behind your mirror line. So therefore this here would represent the point f double prime. We do the same thing for D. We look at the distance from the mirror line. So therefore the double prime should be same distance behind the mirror line. So therefore this is the double prime. And we apply the same thing for E prime. So E is 1, 2, 3, 4 units in front of the mirror line. So therefore its image should be 1, 2, 3, 4. So therefore this point here should be E double prime. So therefore we join these points and we get this triangle here, right? So make sure you understand the properties of a reflection. All the points in front of the mirror line, when we reflect it in the mirror line, the image will be the same distance behind the mirror line. Okay? Oh, and that's the last part. Okay?